Okay, now that we are familiar with some of the structures of alkanes, what happens when these chains start growing beyond the 3 or 4 or even 5 carbons? Do we have a way of naming these things in a consistent fashion? So we're going to study now the nomenclature of alkanes. All of this is based on rules put together by the International Union of Pure and Applied Chemistry, also called IUPAC. And here are the rules. You should have a document that you can download from Canvas that has all these rules and most of what I'm presenting here available to you on a single document. Rule number 1, you're going to identify what is the longest continuous carbon-carbon chain in the structure and use the number of carbons to give the compound its parent name. The first 4 of them, methane, ethane, propane, and butane. And after that, we use Greek prefixes. So for 5 it's pent, for 6 it's hex, for 7 hept, for 8 oct, for 9 non, for 10 dec, and then you add the ending ane for alkanes. All right, rule number 2. Any other carbon-carbon chains are going to be considered as if they were alkyl substituents or attachments or branches. What we'll do is we'll use the YL termination to name them. So for example, a single carbon substituent would be derived from methane, called a methyl group. A 2-carbon substituent would be from ethane, ethyl. A 3-carbon attachment would be propyl. And if it's a 3-carbon substituent attached from the middle carbon, we call that the isopropyl group. We will now assign numbers to the carbons in the parent chain, beginning from one end, so that we can indicate the positions at which each substituent is attached. Here's the key though. The carbon numbering must be done to yield the lowest possible sum of position numbers. Rule number 4, we're now going to place all the alkyl substituents in alphabetical order with their position number preceding each one using hyphens. So the format is, as you can see here, number of position, hyphen, name of the alkyl group, hyphen, number of position, hyphen, name of the other alkyl group, and the last one is simply joined to the name of the parent chain. If there are more than one substituent of the same kind, then we're going to use a prefix, di, tri, tetra, etc., to indicate the number of each. And we'll have to indicate the position numbers for each one of the substituents, even if they're repeated, separated by commas. When we place the substituents, though, the alphabetical order does not include these di, tri, tetra, etc. prefixes. It's just the name of the alkyl group. So in our previous video, you saw these 3 compounds, N-pentane, isopentane, and neopentane. These are common names, and what we'd like to do is have a consistent way of naming them. Well, the first one is simply the 5-carbon chain, so we'll simply call it pentane. Now, when we get to the second one, what you'll notice is that it is based on a 1, 2, 3, 4 carbon chain, to which there is a methyl group attached. And if we count from the left side here, it is going to be at position number 2. Notice that if we were to count from the right side, it would be at position number 3. Therefore, we would call this compound 2-methyl-butane, because in this case, the longest continuous chain is 4 carbons, so that would be butane. In the next example, what we have is, it doesn't matter which way we do it, and actually remember that these don't all have to always be the same thing. Now, naturally, your eyes will try to follow this line here of carbons and arrive at 3. However, notice that you could technically also go, for example, 1, 2, 3 downwards, right? Or you could actually go even this way, 1, 2, 3 to that side. Any continuous carbon-carbon chain in this compound is going to be 3 carbons, meaning that the parent chain is going to be a propane. And now that leaves us with 2 substituents both at the same middle carbon, which would be carbon number 2 on that propane chain. So we would have this compound be named 2,2 hyphen dimethylpropane, or simply 2,2-dimethylpropane. Notice the consistency of the method now allows us to name compounds that are a little more complex than the ones we've been studying. So let's practice with this one. What would be the IUPAC name for this compound? Okay, the first thing we want to do is we want to identify what is the longest continuous carbon-carbon chain. Now, technically, we could start from the top or we could start from the side. I'm going to just draw this one here, and let's see what that is. 1, 2, 3, 4, 5, 6, 7. So that means that the parent name, according to rule number 1 here, is heptane for 7 carbons. Now we had to identify the other chains as substituents. So we have a 2-carbon substituent here and a 1-carbon substituent here. The 1-carbon substituent is derived from methane, would be the methyl group, and the 2-carbon substituent would be derived from the 2-carbon compound ethane, so it would be the ethyl group. Now, keep in mind the first letter of each one of those because that is going to determine alphabetically how we put them in order in the final name of the compound. Now we need to number the carbons on this chain. Remember, we could start from either end, but in this case, it should be fairly obvious that starting from the left side, putting that carbon at number 1 would place therefore the ethyl group at position number 3 and the methyl group at position number 4. And so what we would have therefore is, according to the next rule, number 3 is the ethyl group at C3 and the methyl at C4. These number of positions are what are going to identify where the substituents are when we get the final name. And here it is. We have the parent chain as heptane. We have an ethyl at C3 and a methyl group at C4. So this compound would be called 3-ethyl-4-methylheptane. Notice that we don't put a hyphen between the methyl and the parent name. Sometimes I call it the last name, kind of like a regular person's name. Now I'm giving you a skeletal structure of the ones that we saw in the previous video. What is the IUPAC name of this compound? So the first thing we're going to do is we're going to try to identify what is the longest continuous chain here. Now our eyes might visually decide to go this way, 1, 2, 3, 4, and think that the parent name here would be butane. However, that is not the case. We had to explore all the possibilities. And there's one starting here at the bottom, 1, 2, 3, 4, 5, that gives us a longer chain based on pentane. Having done that, then we realize therefore that this extension here and this extension here are actually substituents, and since each end of a segment represents a carbon with its corresponding entourage of hydrogens, we see that those should be single carbon attachments. Therefore, we have 2 methyl groups in this structure. Now we need to apply rule number 3 and number these different positions. Notice that if I were to use a kind of like my logic, I would try to put this guy at number 1 over here, which means now that my attachments would be at positions 3 and 4. However, if instead of that one, I were to start counting from the carbon on the right, and would call that number 1, then that means that my attachments or my substituents would be at positions 2 and positions 3. Notice that the rule says you have to choose the numbering system that gives you the lower sum of position numbers. Therefore, we're not going to take into account that first attempt that we did. We are going to say that our compound, therefore, has this numbering, which means that now the methyl groups are going to be at positions 2 and 3, not positions 3 and 4. Now we're ready to name our compound. Remember that we have two methyl groups, so we have to call this a dimethyl substituent, and we have to indicate the position of each. Even if both of them were on the same carbon, we would still have to indicate the same position number twice. In this case, the name of our compound would be 2,3-dimethyl pentane. Let's now go the opposite way. I'm going to give you the name of a compound, and you're going to draw the structure for it. What would be the structure for 4-isopropyl 2-methyl heptane? Well, strategically, the way you want to do this is you want to deconstruct it in reverse. In other words, start from the parent name, in other words, the last name, and work your way towards the front of the molecule's name. In this case, our last name is heptane. Therefore, that means that our main carbon-carbon chain consists of 7 carbons. Let's go ahead and do a skeletal structure. So we go 1, 2, 3, 4, 5, 6, 7. And that is our parent chain. Now we see that we should have, according to this, at position number 2, we should have a methyl group. That is a single carbon. So we're going to draw a line pulling out here of carbon number 2, and that is our methyl group. The other substituent says 4-isopropyl. Well, we can see that the number 4 position is right there, but, what is isopropyl? Well, isopropyl means you have a 3-carbon chain that is attached at the middle carbon. So that means I'm going to go back here to position number 4 on the chain and pull out 1 carbon there. And since that's going to be carbon number 2 of the 3-carbon substituent, I'm going to draw 1 over here and 1 over there. And that is my structure for 4-isopropyl 2-methyl heptane. You will have a chance to do some more practice later on, so I hope you enjoyed. Our next topic is going to be other types of alkanes called the cycloalkanes, and also we're going to talk about the unsaturated hydrocarbons, the alkenes, and the alkynes. Thank you very much.